Welcome back, everyone. Welcome to this last part of this particular module. And today's topic is selection of drives for real time applications. So, here first we will see what is a solar powered pump system. This is a solar panel. The solar panel it is made up of semiconductors. When the sunlight falls on the solar panel it absorbs the solar energy. It absorbs the photons from the sunlight, and what it will do? It will generate the electrical energy. DC current it will generate. Then there is a pump controller. Depending upon the water demand and energy efficiency, this pump controller will regulate the start and the stop of this pump. Now this powered pump is powered up from this solar panel. Okay, and it will draw or move water from the water bodies like well, river, pond, and give it to the overhead tank. This overhead tank is placed at a particular height from the ground level where the water is stored. Now from this overhead tank we can set a pipe, and depending upon our application in irrigation system or agriculture we can use the water. So this is all about the solar powered pump system. Next we will see what is solar powered pump drives with reciprocating pump. Reciprocating pump means here the pump uses the back and forth motion for its operation like a piston. So this back and forth motion is called the reciprocating. So here we have what? First we have the solar panel. So this solar panel will convert the sunlight into the electrical energy, and it will provide the voltage and the current, and this voltage and current it is provided to power the system. Okay, and this solar panel it acts as a primary energy source for the entire setup. Next what we have? We have the maximum power point tracker, in short MPPT. So what it will do? It will monitor the voltage and the current from the solar panel to determine the maximum power point, and it will ensure that the solar panel operates at its most efficient point to maximize the power extraction. It will send the optimized voltage and the frequency to the PWM inverter. Next, what will happen? This PWM inverter, it will convert the DC power from the solar panel into the AC power suitable for the driving of your induction motor. Now, this PWM inverter, it will provide the controlled AC power to the induction motor, allowing the adjustable speed and torque. So, full form of PWM is pulse width modulation. By controlling the width of each pulse, we can control the AC signal generated over here. Then this induction motor, it is a three-phase induction motor. We are giving the AC supply to the stator winding of the three-phase induction motor. This induction motor will convert the electrical energy to the mechanical energy, and it will drive this pump to move the water from the source to the storage tank. Next we have this pump. So what this pump will do? It will physically move the water through the pipe, and it is driven by the induction motor. Okay, and it transfers the water from the water source to the overhead tank. So that is the whole process of the solar powered pump drives with reciprocating pump. Next we will see the solar powered pump drives with battery. So like previous cases, here also we have the solar panel. It will convert the solar energy to the electrical energy, and it will provide the renewable energy to charge the battery and power the system. Then we have the charge controller. This charge controller, what it will do? It will regulate the voltage and the current that is coming from the solar panel to prevent the overheating or overcharging of the battery. It will ensure that the battery is charged safely and efficiently, and it will protect the battery from the damage due to excess voltage or current. Next component is my battery. So battery is there to store the electrical energy for use when my sunlight is not sufficient, for example during the night or the cloudy weather. So it will act as an energy reservoir in the system, and it will provide the steady power supply regardless of the solar panel output. Next we have this A and B. These are the switches or connectors. So they are the connection points that will allow the switching or directing the current flow between the different parts of your system. Next we have the chopper. So chopper it is a high speed switching device. So this chopper will convert the DC voltage to a controlled DC voltage with adjustable magnitude using the high frequency switching. Okay. Next, what this chopper will do? This chopper will prepare the DC power to the efficient it will prepare the DC power for the efficient conversion to the AC by controlling the voltage and current levels suitable for the motor. Next we have the motor. This motor will convert the electrical energy into the mechanical energy to drive the pump. And this motor will power the pump, which moves the water or other fluids as per requirement. Then we have the pump. This pump utilizes the motor's mechanical energy to move the fluids, and it will perform the actual work of pumping, which is driven by the motor. Moving on to the next topic, which is selection of drives and control schemes for lifts and cranes. So here we have a AC power source. It will provide the AC current, electrical energy to the system. And it will also provide the initial power needed for the operation, which is then conditioned and converted for use in the system. Then we have this three-phase AC LC filter. So this three-phase LC filter, it is comprises of inductor and the capacitor. Okay, and what it will do, it will remove the harmonics, high frequency noise or any transients from this AC power supply. Okay, resulting in a cleaner and more stable power input to the active front end. Next, this active front end, it is a power electronic converter. It controls the power flow between the AC source and this inverter. What it will do? It will regulate the power quality. It will provide the reactive power compensation and maintenance and control sinusoidal current. It will also stabilize the system and reduce the power disturbances. Next we have this inverter. So this inverter, as we know, it will convert the DC voltage which is obtained from the rectified AC into the AC voltage. Okay, If there is any fluctuation in this power converter output, that also will be removed by the capacitor over here. Next we have this uh, bidirectional DC to DC converter. It will convert the DC voltage from one level to another and can operate in both the directions. What it will do? It will manage the energy flow between the inverter and the supercapacitor. It can also store, the supercapacitor will store the excess energy, or it will supply energy back to the system, which will provide the stability to your system. Now, what are the supercapacitor? As I told, they will store the electrical energy with high power density. They act as the high energy backup to the system. They are super fast batteries. They will provide, if for example, when your system requires extra power suddenly, so the supercapacitor will definitely deliver that power to your system instantly. And after delivering, like if it needs to store, whenever there is some excess power, the supercapacitor will store that electrical power for the future use. Okay, then we have this inverter. This inverter will convert the DC to AC. Then after this DC to AC, we have this three-phase induction motor. Okay, so this three-phase induction motor, at the stator winding of the three-phase induction motor, we give the AC supply, and this motor will convert the electrical energy to the mechanical energy. Next, here this three-phase induction motor, it is connected to the crane hook. So this crane hook can move in three dimensions, either up, down, left, right, or forward and backward, so that it can position the load attached to it exactly where needed. And the crane has its own drive system. That means it has its own connections and components, which will make sure that the acceleration, and the acceleration means speeding up, and retardation means slowing down. So this crane has its own drive system, which will make sure that the acceleration and the retardation of the crane are smooth and even. So this is more important than just controlling the speed itself. Okay. Next, the crane can accurately position this load by adjusting how fast the wheels and motors can move, and it will ensure that the load stays exactly where it should be. So next part is my main components of the electrical vehicle. So in electrical vehicle, we have this electric motor, we have this power inverter, we have the power converter, we have the battery, we have the battery charger, we have the charge port. Now let us see each of these components one by one. So this charge port, what it will do, it will connect the external power grid. This is my external power grid, and it will charge the battery pack. What is battery pack? It is the assembly of the batteries that are used to store the electricity. And this charge port, it is present both in battery EV, that means battery electric vehicle, and plug-in hybrid electric vehicle. What happens in battery electric vehicle? For example, like we are discussing the electric car, right? So when the electric car runs entirely depending upon the electricity stored in the battery, okay, it doesn't have any concept of fuel tank or traditional gasoline engine. That is called the battery electric vehicle. What is plug-in hybrid electric vehicle? Here, that electric car, it, it is having the battery powered electric motor as well as a traditional fuel tank or gasoline engine. So when this car is going for a short trip and if it is plugged in, uh, it will run using the electricity stored in the battery, and when the car is going for a long trip, it will run based on the fuel tank or the gasoline engine. So this is how this plug-in hybrid electric vehicle operates. Next we have the battery charger over here. So battery charger, what it will do, it will convert the AC current received from the charge port to the DC current, and this battery charger, what it will do, it is also used to store in the battery pack. Okay, so it will mainly convert the AC received from the charge port to the DC. This battery charger will help to store the electricity in the battery pack. Next is the battery pack. As I already told, it is a assembly of the battery where it is used to store the electrical energy. It is a set of any number of individual battery cells. It can be configured in series, parallel or combination. Lithium-ion battery is the most commonly used. Next we have the battery management system, BMS. So BMS is an electronic system that manages the battery pack. This BMS will also protect the battery from operating outside its safe operating area. There are some basic functions of BMS called monitoring the state of the battery, reporting that data, controlling the environment, also cell balancing. Next component is the power converter over here. This is a DC to DC converter. Okay, it will take the voltage from one DC source and convert the DC voltage level into another DC voltage level, and it is used to increase or decrease the voltage level. Next part is my power inverter. This power inverter, it will convert the DC current on the battery into an AC current, and it is used by the electric motor to drive the wheels during regenerative braking. What is regenerative braking? Regenerative braking is a system and it is common for both the electric and the hybrid vehicle, where the vehicle's kinetic energy, it is converted to the electrical energy instead of wasting it as heat during the through friction. So during regenerative braking, the AC is converted to DC and they used to recharge the battery. Next we have the electric motor. So it will convert the electrical energy to mechanical energy to drive the vehicle. Next topic is our electric vehicle control schemes. So here first we have the vehicle electrical equipment. So it will include all the electronic parts in the vehicle that need electricity, like lights, radio, sensors, etc. Next we have DC to DC converter. This device changes the voltage level of the electricity from the battery to a suitable level for the vehicle's electrical equipment. Next we have what? We have the battery. So the main source of stored electrical energy is your battery. It will supply the power to the motor and other electrical parts. Next is the motor drive. So this motor drive will control the electric motor. It will manage how much power it uses to drive the car. Okay. Next we have what? Electric motor. This part that turns the electrical energy to the mechanical energy to move the car. Next we have what? We have the reduction gears. So These gears reduce the high speed of the motor to a lower, more useful speed for the wheels. They will help the car to smoothly run and efficiently. They will mainly help the car run smoothly and efficiently. Then we have the rear wheels. So this is that part of the car that actually moves and makes the vehicle go forward and backward.